In this video, we'll be talking about completing the square. Completing the square is an algebraic technique that has lots of useful applications. Before we get into the actual technique, let's look at an example of factoring some polynomials. In our first example here, we want to factor the polynomial x squared plus 10x plus 25. Remember that when we're factoring a polynomial like this, what we need to do is come up with two numbers that multiply to the last number, which in this case is 25, and add up to the middle number. In this case, that's 10. Once we find those two numbers, we can factor our polynomial as x plus the first number times x plus the second number. Now, two numbers that multiply to 25 and add up to 10 are 5 and 5. So our polynomial factors as x plus 5 times x plus 5 again. We notice here that the two factors are the same. They're both x plus 5. So we can group them together and write this as x plus 5 squared. So that's how we factor the polynomial x squared plus 10x plus 25. Let's take a look at another example. In example B here, we want to factor the polynomial x squared minus 4x plus 4. Just like before, we need to come up with two numbers that multiply to the last number, which is 4, and add up to the middle number, which is negative 4. And once we come up with the two numbers, we can factor our polynomial as x plus the first number times x plus the second number. Now, two numbers that multiply to 4 and add up to negative 4 are going to be negative 2 and negative 2. So this means our polynomial factors as x plus negative 2 times x plus negative 2 again. Remember that when we add a negative number, it's essentially the same as subtracting. So we can rewrite this as x minus 2 times x minus 2. Again, we see that we have a repeated factor. The factor of x minus 2 shows up twice. And so what we can do is we can group them together and write this as x minus 2 squared. So this is how the polynomial x squared minus 4x plus 4 factors. In our two examples here, when we were looking for the two numbers that multiply to the last number and add up to the middle number, the two numbers ended up being the same. Like in our first example, the two numbers were 5 and 5. In our second example, the two numbers were negative 2 and negative 2. Since the two numbers were the same, we ended up with repeated factors, and so we can group them together to get x with some number all squared. Since these polynomials factor in this way, we say that these polynomials factor as squares. When we're talking about completing the square, we're essentially working with quadratic polynomials. We're going to try to figure out a number that we can add to the quadratic so that it can factor as a square. Let's take a look at some examples. In the examples that we're going to be working with here, we'll be given a quadratic polynomial, and what we need to do is figure out a number that we can add to the polynomial so that it factors as a square. In our first example here, we have x squared plus 6x. We need to come up with a number that we can add on at the end here so that it factors as a square. Remember that when we're factoring a quadratic like this, we want to rewrite it as x plus some number times x plus another number. However, if we want to factor this as a square, our two numbers here have to be the same. That way we can group the factors together as x with some number all squared. So the question is, what is that number? Remember that our two numbers here have to add up to the middle number and multiply to the last number. So if the two numbers add up to 6 and they have to be the same number, our two numbers have to be 3 and 3. So now, what does our last number here have to be? Remember that the two numbers here have to multiply to the last number, so in this case, 3 times 3 gives us 9. So basically, if we started off with the quadratic x squared plus 6x, if we add 9 at the end here, then our quadratic is going to factor as x plus 3 times x plus 3, which we can group together as x plus 3 squared. This process is what we call completing the square. We started with a polynomial, we added a number at the end so that it factors as a square. Let's try another example. in example B here, we're working with the polynomial x squared minus 14x. We need to come up with a number that we can add on at the end so that we can factor this as x with something squared. Again, if we're factoring a polynomial like this, we're going to end up with x plus some number times x plus some other number. And if we want this to factor as a square, our two numbers here have to be the same number. When we're factoring, the two numbers have to add up to the middle number, negative 14, and multiply to the last number. Well, if the two numbers are the same and it adds up to negative 14, then our two numbers are negative 7 and negative 7. And now, if we want to figure out what number goes at the end here, all we have to do is multiply our two numbers. So negative 7 times negative 7 gives us 49. So if we start off with the quadratic x squared minus 14x, if we add on 49 at the end there, then our polynomial is going to factor as x plus negative 7 times x plus negative 7, which we can group together as x plus negative 7 all squared. And again, if we're adding a negative number, it's the same as subtracting. So we can rewrite this as x minus 7 squared. Again, the process of adding this last number so that our quadratic factors as something squared is called completing the square. So let's try to figure out the general pattern here. So in our third example, we're just going to have the quadratic x squared plus bx, where b is some unknown number. What we want to do is figure out a number that we can add on at the end so that it factors as a square. So remember, if we want to factor this, it'll look like x plus something times x plus something else. And if this factors as a square, then the two numbers here have to be the same number. Since the two numbers here have to add up to this middle number, b, and they have to be the same number, our two numbers must each be half of b. So we can write in these spots b divided by 2. And this fits the pattern of what we've been working with before. In example A, the middle number was 6, and the way it factored was x plus 3 times x plus 3. Right? The 3 here was half of 6. In example B, our middle number was negative 14, and the way our polynomial factored at the end was x plus negative 7 times x plus negative 7. These two numbers were each half of negative 14. Now that we know how our polynomial has to factor, let's fill in this last number here. Remember that the last number is the product of the two numbers, b divided by 2 times b divided by 2. So multiplying those together, we get b divided by 2 squared. So to complete the square on x squared plus bx, what we need to do is we need to add on b divided by 2 squared. And once we do, our polynomial factors as x plus b divided by 2 all squared. Let's use this general pattern that we figured out to do one more example. In example D, we have the polynomial x squared minus 20x. Once again, we want to figure out the number to add at the end here so that we can factor it as a square. So in our general pattern, if the middle number was b, the number we add on at the end was b divided by 2 squared. So in this example, our b is negative 20, which means the number that we want to add on at the end here is going to be negative 20 divided by 2 squared. Negative 20 divided by 2 is negative 10, and if we do negative 10 squared, that's going to give us 100. So the number we need to add on at the end to complete the square is 100. And once we add on 100, we'll know that this factors as x plus b divided by 2 squared, which in this example is going to be x plus b divided by 2 is going to be negative 20 divided by 2, or negative 10 squared. And we can simplify this as x minus 10 squared. So a general pattern that you'll notice is that once we add on that last number, our quadratic is going to factor as x with half of this middle number squared. Now, before we close out this video, I want to look at one practical application of completing the square. One thing we can use completing the square for is solving quadratic equations. Now, one approach for solving this equation is by factoring. So for example, what we can do is we can try to factor x squared minus 8x minus 20. To factor this, we need to come up with two numbers that multiply to negative 20 and add up to negative 8. Those two numbers are going to be negative 10 and positive 2. So our polynomial here factors as x minus 10 times x plus 2, and this equals 0. Now, when a product of two things is equal to 0, this tells us that either the first factor equals 0 or the second factor equals 0. So this tells me that either x minus 10 equals 0 or x plus 2 equals 0. And solving each of these individual equations, we get x equals 10 and x equals negative 2. So this is one approach for solving a quadratic equation. But this is not the only way we can go about it. We can also solve this by completing the square. So let's take a look. So let's say we have our equation x squared minus 8x minus 20 equals 0. What we can do is we can start by moving that negative 20 to the other side by adding 20 to both sides of this equation. This gives me x squared minus 8x equals positive 20. What we're going to do now is we're going to try to complete the square on the polynomial on the left-hand side. So if we have x squared minus 8x, we want to think what number can we add on at the end here to complete the square. Remember, what we want to do is we want to take this middle number, we want to divide it by 2 and square the result. So negative 8 divided by 2 gives us negative 4, and negative 4 squared gives us 16. Now we can't just add 16 to one side of the equation. Anything that we do to one side of the equation, we also need to do to the other. So if we add 16 to the left-hand side, we also need to add 16 to the right-hand side. Since we've completed the square on the left-hand side, we know that it factors as a square. Specifically, we can factor it as x minus 4 squared. Remember, our general pattern is that the number that's with our x is always half of this middle number. On the right-hand side, 20 plus 16 gives us 36. Next, if we want to solve for x, what we can do is we can take the square root of both sides to undo the square. That's going to leave me with x minus 4 on the left-hand side, and then we have plus or minus 6 on the right-hand side. We need that plus or minus because whether x minus 4 is positive or negative 6, when we square it, we're going to get positive 36. One last step here is to add 4 to both sides, and we end up with x equals 4 plus or minus 6. Now, if we choose the plus option, x would equal 4 plus 6, which gives us 10. And if we choose the minus option, x equals 4 minus 6 gives us negative 2. So the answers that we got here, x equals 10 and x equals negative 2, match up with the answers that we got when we used the factoring method for solving this equation. While the approach of completing the square requires more steps, this method of solving quadratic equations works even when you can't factor the polynomial. So in this video, we've learned how to complete the square on quadratic polynomials.